Hey everybody, this is probability video number 10, and we're going to talk about the OR formula for probability, and this is our introductory thing. So one of the things in probability is the first section is super simple, where you've just got probability is equal to your event, what you care about, over your sample space. And the most complicated thing that we did in that section was occasionally we had to something about cards, like how many 5-card stud hands can you get that are all hearts or something like that. And then you had to use combinations to figure out both the event and the sample space. So this part, we have to look at whether the things in our sample space are well, mutually exclusive or non-mutually exclusive. In other words, we're going to work a little bit with figuring out our sample space and also the event. So what are our probabilities? But now that I've got you all concerned and confused, let's just take it slow. I know we can do this. So big deal. We're still talking about one event. Later on, we're going to talk about 2 or more, but right now, 1. And you should know from, let's see, math 20 and math, when we did set notation and all that, that mutually exclusive or disjoint sets have nothing in common. Okay. You know what? I think y'all should pause it. Sorry, my Southern drawl is coming out, even though I'm not from the South. Fill in this stuff. You should know that. It's not like we haven't done this. All right, I'm going to trust you did. So my Venn diagram, there's a circle for my first thing. There's my circle for the second thing. They are mutually exclusive. They are disjoint. They have nothing in common. Whereas non-mutually exclusive or overlapping events have something in common. And you know, I just realized this is the normal diagram. And of course we know, boop, 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 boop. That's the part we have in common. But really in this section, we can even include when you're talking about a subset. Okay. So we have some probability formulas, which should look familiar from the set notation section. Before there were kind of n's in front, now there's P for probability. So this stands for the probability of event A, or remember, this is the union sign, so it's or B is equal to the probability of A plus the probability of B. Pretty straightforward. Okay, so when they have nothing in common, you just add up the 2. Done. But when they do have something in common, the probability of A union B is equal to the probability of A, you know that, plus the probability of B, minus the probability of A and B happening at the same time. And again, that should feel so familiar from before. All it's saying is if I count everything in this circle and everything in this circle, I've counted this middle part twice, so I have to adjust for it. Ta-da! There we go. These formulas, I think you will use much more than we did in set notation because we just drew the diagrams and figured it out. All right. So the only difference between the formula is this part. And here's a super trick for you. If you want, you can use this formula every single time. You'll never go wrong. But if it's actually something where this is the one you should have used, that overlap is going to be 0, right? If you look at the picture, there's no overlap. So the probability of green marbles and blue marbles at the same time is 0. So when in doubt, this is going to be your favorite formula. All right, let's take a look at some examples here. And we are going to figure out identify the following as mutually exclusive. Again, nothing in common. Or if you want to think no overlap, exactly the same idea. And these ones, I'm just going to write overlap. It's faster. Or something in common. So if I have I was thinking I should go get a deck of cards, but it's okay. Picking a 4 and a 10 at the same time. So if you take your cards, a deck of cards, and you pulled out all the 4s, you pulled out all the 10s, is there any that, hold on, I'm going to pause the video. And I'm going to go get me a deck of cards. Okay, I'm back. I just feel better actually being able to do this and show you, even though I know you know what I'm talking about. All right, ta-da. There I have my 4s. And there I have my 10s. And there's nothing in common. If I said, ask probably picking a 4 and a 10, you're not going to say, well, here's a card and it's a 4 and a 10 at the same time. No, it's not. So they have nothing in common, which makes them mutually exclusive. Now, it's a, I can say it says picking a 4 and a club. All right, so here are my 4s. But when I go to do my clubs, this 4 can also, or does also, oh, I got my numbers wrong there, whatever, belong over here. So if it can fit in both of the sets, so it can be a 4 over here, it can be a club over there. Okay, this is just really bugging me that I got the 5 in the wrong spot, sorry. Then that's not mutually exclusive. All right, now let's see about picking a red card and a heart. So if I pull out, I was going to say, y'all should just get out of deck cards. I'll pull out all my red cards and all my hearts. All those years playing cards on the school bus are finally paying off. All right, all the rest of those are black. Now, if I take this pile, okay, you can see them all. Those are all the red cards. And I know there's 26, right? So now what's the chance of me picking a red card? Oh, and here are all the hearts over here. Well, what are the chance of me picking them at the same time? Well, yeah, because it's not only like the 4 where it was one card that fit both qualities. Every single one of the hearts cards is also part of the red card pile. So those are definitely not mutually exclusive. All right. Now what's next? Let's say picking, I think, again, as always, pause the video, try it yourself. Okay, so you think about that while I dig out all this stuff. Okay, so now here is the pile of spades. I'm too lazy to put them in order. There, do that. Boop. There are all my spades. And then it says picking a heart at the same time. There are all the hearts. Is there any card that's going to fit in here and here at the same time? Yeah, no, of course not, which means they're mutually exclusive. They have the group of spades and the group of hearts are mutually exclusive. There's no common element to the two of them. All right. Rolling a sum of 12 and rolling a sum of 8. Oh, I guess we're done with cards for now. So we're talking, I guess I missed a few words there. Rolling a sum of 12 and rolling a sum of 8 at the same time. You could, I'm not going to do it all because it takes a while. You could go through on a test. I would definitely do this. Remember we talked about that with at the beginning, where this is the first die and that's the second one. And this is, so this is a 1 on each. This is a 2 on the first one and a 2 on the, and a 1 on the second one. And you would go through and eventually you'd have 6 and 6 down here. Okay. But I think you can figure it out. Rolling a sum of 12 and rolling a sum of 8 at the same time isn't going to work, right? Because the only way you get 12, by the way, would be down there. And then you're going to have several options to get a sum of 8. But you can't have a total of 12 and 8 at the exact same time. So that means they're going to be mutually exclusive. This says rolling a sum of 12 and rolling an even number at the same time. Well, yes, because 12 is an even number. So those two things can happen at the same time. So that makes them non-mutually exclusive. Let's see, rolling an even number or a multiple of 5. Oh, okay. I'm just going to finish this off because it's getting a little heady for me. While I'm having fun here, either you can do the same thing or fill in those. 21. All right. So those are all our possible choices. And I know I have them all because there are 6 sides on my first die. And there are 6 sides on my second die. And that's 36, and there's 36 pairings in here. Okay, back to the question. Rolling an even number or a multiple of 5 with 2 dice. Okay. So my even numbers, I probably should fix this question. Because rolling an even number, to me, looks like it doesn't say I had to have 2, just says, and it didn't say some. So I'm just going to pretend that at least one of my dice has to have an even number. No, there. Whoops, that's the wrong one. Should be this one. I think I've got them all. So it should be that column, that column, that column, row, and then this column, and this. Yeah, I think we're good. Anyway, there's an awful lot of them. Or a multiple of 5. So are any of these multiples of 5? You know what? I really got to fix that question. Because it should be, you know what? I'm just going to fix that question. I'll take it off. Rolling an even sum or a multiple or a sum, that's a multiple of 5. All right, just skip this question. I don't feel like redrawing this, but that's on me. I didn't make that question very good. Okay, rolling doubles and rolling a sum of 10 at the same time. Okay, that one we can do. Here are my doubles. It's easy. 1, 2, 3, 4, 5, 6. And rolling a sum of 10. Now for a sum of 10, 1, 2, 3. So if you notice, 5 and 5 fits both of those criteria. So that's going to be not mutually exclusive. Now, rolling doubles and rolling a sum of 7 at the same time. So there's my doubles. Now a sum of 7 is going to be these numbers, but I think you already know that there's not going to be any overlap, because if you add these up, you never get 7. So these are going to be mutually exclusive. Oh, let's just make it simpler. Scoring 1 goal or scoring 2 goals. Pretty much it's either or. So when you're in either or, that means they're mutually exclusive. Scoring 1 goal or winning the game. That could happen at the same time. You could have a game that, I don't know, maybe soccer or a hockey game or something like that, where you have 1 goal and that's the entire game. So that could happen. That could happen at the same time. Tossing a coin and getting heads or tails. It's either or. Either you get heads or you get tails. There's no intersection between the two of them. So that should be mutually exclusive. Turning right or sneezing. I'm sure you can imagine a scenario. You're driving, you turn right and you sneeze. These two can happen at the same time. So that's not mutually exclusive. And turning left or right. Yeah, you can't do those at the same time. All righty. So, oops. You can do the two things at the same time. So that's not mutually exclusive. Cannot do them mutually exclusive. What did I say? Overlapping events and disjoint sets. All right, that's it for this video. Sorry about that one question, but when we take it up in class, we'll have it straightened out. Oh, it's been a while. I got to remember how to do this. Stop recording. Yes.